In the previous videos, we have seen the least cost method and the northwest corner rule for establishing an initial feasible solution for transportation model. In this video, we'll see another alternative method, which is Vogel's approximation method for finding out the initial feasible solution for a transportation model. Now, the northwest corner rule generally does not yield the best solution since it does not take into consideration the transportation costs. And the least cost method, although provides a better solution by allocating as many units as possible to the lowest cost cell in the table and then to the next lowest and so on, but sometimes we are forced to use the highest cost cells towards the end of the initial allocations. The Vogel's approximation method overcomes this deficiency by making allocation first to the cell with the highest opportunity cost or penalty cost. Now, what is meant by opportunity cost or penalty cost? So let us understand that using a simple example. So let's say that there are 2 plants and 3 distribution centers. A and B are the plants and P, Q and R are the distribution centers. The cost of transporting from A to P is, let's say, 2 rupees, A to Q is 5 rupees and A to R is 8 rupees. Cost of transportation from B to P is 4 rupees per unit. B to Q is 15 rupees per unit and B to R is 20 rupees per unit. Now let's say the demand at P is 3, Q is 10 and R is 10, and supply at A is 3 and at B is 20. Now based on the least cost method, you first find out which cell has the least cost. So AP has the least cost, which is 2 rupees per unit. So you'll try to allocate as much possible to this cell. So here the supply is 3 and demand is 3, so you will allocate 3 units, and what that means is this becomes 0 and this becomes 0 as well. Now as soon as you allocated 3 to AP, you have crossed off the other squares, or you have removed the other squares from the possibility of further allocation. So now you only have 2 options, cell BQ and BR. The total supply is 20 and demand is 10 and 10, so you'll allocate 10 to BQ and 10 to BR. Now let's see what is the cost here. So 3 multiplied by 2 is 6, plus 15 multiplied by 10 is 150, plus 20 multiplied by 10 is 200. So this becomes 200 plus 150 is 350 plus 6, so 356. Now here, the biggest disadvantage is that you had to allocate 10 units to this cell, which is BR, which has the highest cost of 20 rupees per unit. Now what Vogel's approximation method is saying that you can avoid this from happening if you found out the opportunity cost or the penalty cost. Let's say instead of allocating these 3 units to AP, we didn't allocate this to AP and instead we allocate these 3 units to BP. So here you will allocate 3 units to BP. So this allocation satisfies this demand, so this has become from 3, this has become 0 and this has become 17. Now after allocating 3 units to BP, let's say we allocate 10 units to BQ. So this demand becomes 0 and this becomes 7. Now there's a demand of 10 for R and supply of 3 is available for A and 7 for B. So let's allocate 3 here and 7 here. Now let's calculate the cost for this scenario. So BP is 3 multiplied by 4, which is 12, plus 15 multiplied by 10, 150, plus 7 multiplied by 20 is 140, plus 8 3s are 24. So 150 plus 140 is 290. 290 plus 24 is 314, plus 12 is 326. So this time we got a total cost of 326 as compared to 356 which we got last time. So what we did in the second method was that we took the row B, which has a higher opportunity cost or a higher penalty cost, because the difference between the lowest and the second lowest was the highest amongst A and B. So if we look at this closely, we'll realize that the 3 additional units which we had allocated in the least cost method have now been moved to the cell BP, and the 3 units which were allocated to AP have now been moved to, let's say, AR, or you can say the other way around. I mean, these 3 here have been moved to BP and the 3 units for BR have moved up to AR. But either ways, the cost has now reduced by 20 multiplied by 3, which is 60, and it has increased by a certain amount. However, the increase is not as high as the reduction that we have achieved here, and that is why we overall got a reduction of 30 rupees in the total cost. So the penalty cost or opportunity cost is determined by finding out the difference between the 2 lowest costs for each row and column. We will first choose the row or column having the largest opportunity cost. If we don't allocate as many units as possible now to the cell with the lowest cost in that row or column, we may have to allocate units later to the cell with the next largest cost in that row or column. Now, this table here is the transportation table that we had formed in step 1 of solving the transportation model. In blue on the left hand side, we can see the plants A, B and C, and on the extreme right we have the supply availability at each of these plants, which is 6, 1 and 10. On the top, P, Q, R, S are the distribution centers, and they have demand of 7, 5, 3 and 2 respectively. Now in these cells we have the unit cost of transporting from one plant to the distribution center. So now let's see step by step how we can use Vogel's approximation method to arrive at a solution for this transportation table. So step 1 is to calculate the difference between 2 minimum elements for each row and each column. So calculate the difference between 2 minimum elements for each row and each column. So let's start with the column P. Now for column P, the lowest number is 1 and the second lowest is 2. So the difference between 2 and 1 is 1. So let's note down that here. For column Q, the lowest is 0 and the second lowest is 3. So the difference between 3 and 0 is 3. For third column, 6 and 11. So 11 minus 6 is 5. For the fourth column, S, difference between 1 and 7. So 7 minus 1 is 6. Now looking at the rows, so for A, the lowest is 2 and the second lowest is 3. So 3 minus 2 is 1. For row B, the lowest is 0 and the second lowest is 1. So 1 minus 0 is 1. And for row C, the lowest is 5 and the second lowest is 8. So 8 minus 5 is 3. So here we have completed the step 1, which is to calculate the difference between the two minimum elements for each row and each column. Now step 2 says that select the row or column with the largest difference. So here the largest difference is 6, which is for column S. So we completed step 2. Now step 3 says allocate maximum number of units to the square with the minimum cost in the selected row or column. So allocate maximum number of units to the square with the minimum cost in the selected row or column. So in this case, column S is the selected column. Now within the selected column, we have to allocate the maximum number of units to the square with the minimum cost. So the square with the minimum cost is BS and the cost is 1. Now we have to allocate the maximum possible to this square. Now B has a maximum supply capacity of 1 unit, while S has a demand of 2 units. So the minimum is 1 and we can't supply more than 1 from B. So even though the demand is 2, we can only allocate 1 to the square BS. So we'll allocate 1 here. Now what this means is that the demand at S reduces by 1 unit, so this remains as 1, and the supply at B also reduces by 1 unit, so this becomes 0. So with this we have completed step number 3. Now step number 4 says that cross out the row or column completed by the assignment. So cross out the row or column completed by the assignment. So in this case, since we allocated 1 unit to the square BS, B has completely utilized its capacity of 1 unit. So now B cannot supply to any other distribution centers. So here we'll put a cross on the other squares for plant B. For S we can't put a cross for the remaining squares because there's still a demand of 1 which is unfulfilled. So now let's move to step number 5. Now step number 5 says redetermine the row and column difference for each row and each column except the filled squares and crossed out squares. So redetermine the row and column difference for each row and each column except the filled and crossed out squares. Let's start with column P. So now the minimum is 2 and the next minimum is 5. So the difference is 5 minus 2, which is 3. For Q, 8 minus 3, which is 5. For R, 15 minus 11, which is 4. For S, 9 minus 7, which is 2. Now coming to the rows. So for row A, the lowest is 2 and the next lowest is 3. So the difference 3 minus 2 is 1. Now we'll skip row B because all the squares are either filled or crossed out. So moving to row C, the lowest is 5 and the next lowest is 8. So 8 minus 5 is 3. So we'll put 3 here. We'll put a dash here, means not applicable. Alright, so this completes step number 5. Now step number 6 says repeat steps 2 to 5 until all assignments are made. So repeat steps 2 to 5 until all assignments are made. So now step 2 is select the row or column with the largest difference. So here the largest difference is 5. So we'll select this column, which is Q. Now step number 3 says allocate maximum number of units to the square with the minimum cost in the selected row or column. So for Q, the cell with the minimum cost is AQ. So to AQ, we'll try to allocate the maximum possible. Now for Q, the demand is 5 and for A, the supply is 6. So even though we can supply 6 but demand is only 5, so the maximum we can allocate is 5 units. So here let's allocate 5 units. So what this means is that the demand at Q now becomes 0 and the supply capacity for A is now 1. So now step number 4 is cross out the row or column completed by the assignment. So since the demand for Q has completely been fulfilled, we'll cross off the squares which are not yet allocated or crossed off. So we'll cross off this square CQ. We can't cross off the other squares for row A because there's still a supply of 1 which can be allocated to the other distribution centers. Now the next step is redetermine the row and column difference for each row and each column except the filled and crossed out squares. So now let's start again with the column P. So for column P, the lowest is 2 and the second lowest is 5. So 5 minus 2 is 3. We'll skip Q because all the squares are either allocated already or crossed off. So we'll put a dash here. The next one is R. So 15 minus 11 is 4. Next one is S. 9 minus 7 is 2. Now move to the rows. So for A, 2 is the lowest and 7 is the second lowest. So 7 minus 2 is 5. For B, everything is either crossed off or allocated, so we'll skip this. And for C, the lowest is 5 and the second lowest is 9. So 9 minus 5 is 4. So now we'll choose the row or column which has the highest difference, and that is row A, because 5 is the highest. Now in this row A, let's find out the cell with the lowest cost, which is AP. Now let's try to allocate the maximum possible to this square AP. So at P, the demand is 7, but for A, the capacity or supply remaining is 1. So even though the demand is 7, you can only supply 1 unit. So we'll allocate 1 unit here. Now with this allocation, the unfulfilled demand at P becomes 6 and the supply availability becomes 0. So now since the supply availability at A becomes 0, A cannot supply to any other distribution centers now. So let's cross off the other distribution centers. However, at P, demand is still remaining. So we'll keep the remaining boxes which are not allocated or crossed off as open. Now we only have one row which is open, which is C, and it has a supply capacity of 10 units. And we have 3 distribution centers whose demand is unfulfilled: P, R and S, with the demand of 6, 3 and 1, which is also 10. So what that means is we can allocate 6 units to cell CP. So when we do this, the demand at P becomes 0 and supply at C becomes 10 minus 6, which is 4. So now moving to distribution center R, demand is 3 and the supply capacity available is 4. So we'll allocate 3 here. So the demand becomes 0 and capacity becomes 4 minus 3, 1. Now for cell CS, the demand for S is 1 and the supply availability at C is also 1. So here we'll allocate 1 unit. So demand becomes 0 and supply also becomes 0. So now here we have completed the allocations. So this forms our initial feasible solution. Let's find out the cost or the total cost achieved by this allocation. So we have shipment from and to, units shipped, transportation cost per unit, now this is in hundreds, and the total cost. So first shipment is from A to P, unit shipped is 1, the transportation cost is 2, so 2 multiplied by 1 is 2. Next is A to Q, the unit shipped is 5, the transportation cost is 3, 5 3s are 15. Next allocation is B to S, unit shipped is 1 and the transportation cost per unit is 1, so 1 multiplied by 1 is 1. Next allocation is C to P, unit shipped is 6, unit cost is 5, 5 6 are 30. Next allocation is CR, unit shipped is 3 and transportation cost is 15, 15 3s are 45. Next allocation is CS, units shipped is 1, transportation cost is 9, the total is 9 multiplied by 1 is 9. So here 15 plus 30 is 45. 45 plus 45 is 90. 9 plus 1 is 10. So 90 plus 10 is 100. And 2 is 102. So 102. So the total cost is 102 multiplied by 100, because this cost is in hundreds. So this is 10200 rupees, or 10,200 rupees. So this is the total cost which we have achieved using the Vogel's approximation method. Now using the least cost method, for the same example, we had arrived at a total cost of 11,200 rupees, whereas with the northwest corner method we had arrived at a total cost of 11,600 rupees. So here you can see how Vogel's approximation method can help minimize the total cost of a transportation problem.